In this video, I'm going to be making a split ergonomic keyboard. Specifically, this is a Dactyl Manuform, and the Dactyl Manuform is this parametric ergonomic keyboard design, and that means that you can actually modify all the key layout, spacing, angles, the tilt, the height, kind of everything on this to your own specific requirements. Now, I used a pretty generic kind of default layout. The only thing that I really changed was removing some keys here because I thought that, I'd probably constantly be pushing these. And then I went with a 4-key thumb cluster here. So it is kind of interesting because it does use these thumb clusters, and I'm going to have to get used to kind of all of this. If you're not familiar with ergonomic keyboards, they are all curved, and that's supposed to limit the amount that you're going to have to move your hands around, keep your wrists in better alignment, and so on and so forth to limit carpal tunnel development. So this specifically is the 6x7 model, and so that means I've got 6 rows and 7 columns of keys. I chose that. It's one of the larger designs because that gives me a bit more of a keyboard. A lot of the designs are quite small, and they basically are just for the text keys, but this runs on QMK software, the quantum mechanical keyboard project, and that allows you to designate keyboard layers, and everything is fully configurable so that you can have whatever key map you want on this thing. And I will probably modify the key map of this keyboard over time to adjust to kind of how I end up using it. Now, the case is 3D printed. I've printed this out of PLA. The two halves are connected by a TRS cable, and there's various designs on how to do this. Some of these are direct wired, some of them use like a RJ45 jack. I chose the 1/8" connector just because I thought that that would be pretty easy to use. Inside of these, there are 2 Arduino Pro Micros, and the versions I got actually have USB-C ports. If I had it do over again, I don't know whether or not I would get that version. The reason is they are not actually USB-C. They just have the USB-C physical port. That's caused some problems because I've had to find very specific USB cables that will work with it. But otherwise, I have not used this a whole lot. I do have it all up and functioning, but it is going to take me some time to get used to kind of the keyboard layout. And so, I don't know if I'll end up enjoying this or even keeping it, or whether I'll just kind of end up throwing this to the side as cool but not actually useful. But the first thing we need to do is look at how you design the enclosure for these, and then we'll get into the rest of the build and design. Okay, so to do the design work, we're going to use this online tool at ryanis.cool, and it is the Dactyl Keyboard Configurator. And it's pretty easy to use. You can just choose all the different types of Dactyl Manuforms that you want. And so I decided to go with the default. And again, you can also change the number of columns and rows. And this is where you can also change all the curvature and offsets and anything you want. This viewer is also able to be spun around. And then you get down to the shaping, and this is where you can do all your different kind of spacing. Do you want the keys wider apart? You can change the stagger of these rows, and tons of configurability in here. And down here at the bottom, if you want the left side, you can just unclick and it will switch, and you can export the left side. If you want the plate for the bottom, you can also do that. Now, once you're done with this, at the top, you just click Download Model, and it will create and export an STL. And at that point, we just need to 3D print this thing. All right, so we've got our 3D print of the enclosure. It turned out okay. So let's get this thing cleaned up, and then we'll talk about how you use this enclosure. So with the model all cleaned up, we can take a look at it really quickly, just to kind of see what we're looking at. So the way these things kind of work, I'm not sure if you'll be able to see, but there's these little nubs on the inside of the model, and that's where an MX style key can lock in. So you press them in, they should kind of click in, but this being 3D printed, the tolerances aren't perfect, and so it's not uncommon for people, once they get their keys in, to then hot glue on the back side to really make sure that they're kind of solidly mounted in the frame here. So this was the kind of demo model that I threw together. It's printed in a much thicker layer height with a much larger nozzle, so the quality of this wasn't quite where I wanted anyway, but it's just kind of a fast thing that I cranked out. So on this one, I also included the screw mounting points that the configurator kind of includes. On my final version, I actually put in my own, and that was basically I imported the STL into Fusion 360, converted it into a solid model, and then just added those wherever I wanted them. But a couple of changes from the demo that I made is I'm omitting one key on the pinky, and also I got rid of this gap for this kind of pinky column. Otherwise, I pretty much kept the thing, you know, the same way as spec'd in the configuration kind of base. So just to show you what's going to happen is you're going to take all your keys, and you'll see that they have kind of locking points on the sides. You insert them into the holes and just press, and now they're going to be mounted in, and you'll have access to the back side for wiring. Now let me go ahead and I'll get this thing populated. Now, because I know somebody will ask, these are Gateron Browns, and this is their Pro 3 version. So again, that's just personal preference. So these are kind of a softer key, but they do have a little bit of tactile feedback. So there's a bit of a break point in there, but it's not real strong. Another thing that I would say, just as a tip, whenever you're putting these things in, I do like to have a keycap on them, just because that gives you something to kind of push on, and they can be pretty stiff getting them into the frame. You don't have to worry too much about what key goes where, because you can always pull the keycaps off and just reassign any key wherever you want in the software. All right, there we go, and I've got the keys mounted. I do think I am going to go ahead and take the extra step and hot glue these in. I'm also going to go ahead and at the same time add in threaded inserts. The other thing before I move too far forward, on the 3D print on the filament you use, obviously you can use kind of anything for this, but I chose to use a really high quality PLA from a company called Push Plastic, and they use a really high quality stock for that PLA from a company called NatureWorks. It's NGO 4043D, and if you've never used like really good PLA, it's really interesting because it's a really strong, stiff plastic. A lot of the PLAs these days are like PLA pluses, where they've got additives to help them print better, to have a little bit better high temperature performance, and to not be so brittle. This doesn't have as much of that, and so it can be a little brittle if you print really thin things with it. But man, in a 3D print like this, it is extremely rigid and very strong. It's stronger by quite a bit than ABS or ASA. I mean, it's close to the strength of polycarbonate, and I think it's stiffer. It's almost as stiff as most of the like carbon fiber added, like the stiffest stuff. The base PLA is almost that stiff. So, you know, there's just a plug. Again, I use Push Plastic for this one. There are a few other companies that use that. I think Protopasta also uses the 4043D, and there are a few others. And so again, it costs a little bit more. It's like 30 bucks for a kilo or something like that. But for, you know, again, this application, I think it's worth buying a spool of it. All right, so I got all the keys glued in, and whenever you're doing this, just a couple tips. Try to stay away from the contact points, because I am going to have to come in and solder a bunch of point-to-point wiring in here, and you don't want hot glue interfering with your solder joints. Next thing to do is start working on the wiring. So we'll go get a soldering iron out, and I'll start showing you how all the wiring of the keys is going to work. So it's time to get this thing wired up. And so we're going to use matrix wiring. And so that basically forms a big grid. So you're going to have one connection for each row and one connection for each column. And that reduces the number of pins you need on your microcontroller to satisfy all the keys at the same time. So basically on each row, we need to tie one of the pins together. And on each column, we need to tie one of the pins together. So whenever you push a key, it will correspond to two specific pins on the microcontroller, and it knows exactly which key that's going to be. Now, to make that work for in-key rollover, you've got to use a crap ton of diodes. So that's what I have here. So on diodes, they are directional. So if you see the black stripe, that means the signal will be traveling this way. And so we're gonna tie that so that the black stripe is facing away from the pin. And that's gonna prevent any voltage from any other key from reversing direction and going backward and screwing up any signaling that's going on. So what we need to do then is each successive diode needs to be connected below the black stripe. So you can think about it, there's basically going to be a rail here that everything connects to, and between that rail and the pin sits the diode. So here you can see what I mean. So for each switch, the signal can come out of this pin, it will cross a diode, and then it will go unimpeded into the output. So each switch will have its own diode individually. Now, I won't lie to you, that was indeed just tedious getting all this done. So at this point, we have all the diodes wired in and we've made all of our other connections. So what I've got to do next is just add on leads, because I will eventually be wiring this into some Arduino micros. And so what I think I'm going to do is actually put on some DuPont connectors, and that will allow me to disconnect this or reconnect this without having to desolder or anything. All right, well, we got her all wired up. It wasn't exactly the fastest process. This did take 2 or 3 hours to do, just because there's a lot of little fiddly stuff. So the way this thing is wired, I've got rows and columns, and so you can see each column tied together in each row, and so I'm using the diodes here, and each switch goes through a diode to kind of a rail for each row, and then the columns will not need diodes. Now I've tied all that into to 2 pin headers, and we're going to be using an Arduino Pro Micro, and I've got pin headers also on it. I will say, if you ever do one of these, pay very close attention to the order of the headers and how that corresponds to your rows and columns. So one of the reasons that this took me a while is that I actually had to redo this, because I got it all wired up and then realized that the row and columns were switched from the way that the firmware that we're going to be using was built. And I originally thought that wasn't going to be a problem, because I thought, oh, I'll just change it in the firmware code. You can do that, but it's a little bit more involved than I thought. So it turned out to be faster just to move the wires around. I've also got another header here wired on. So this is for the serial communication, and that's done via a TRS cable, which you may know as just a 1/8" headphone jack. That's basically the cable that's going to connect this, and that's the fun part about this taking a couple hours, is that you actually have to do it twice. Right, so I've got a whole nother one, so this takes quite a while to get all wired up. But now that it's wired up and I've got both sides, we're going to head over to the computer and we'll get the firmware set up and then flashed. Okay, so now we're going to get this keyboard all programmed, and we're going to be using QMK firmware. Now, it's worth understanding that I am on Fedora 40 Linux, so that will influence some of the choices I make as I go through the programming of this keyboard. So we're just going to follow the QMK's tutorial. So we say get started, and I'm actually going to go to use the source, and this tutorial will get your environment set up on your computer. That way you can program the QMK firmware over to these Arduino Pro Micros. So we're going to start off with setting up the environment. Now it says the prereqs, we need a text editor. Any text editor will do. You can also use the QMK toolbox. That is not available for Linux, so I'm going to have to do everything from the command line, but that's not really that big of a deal. It's not that hard. So for the preparation, we just click on Linux, and it tells you for various distros what you need to run. Okay, so since I'm on Fedora, I'm just going to copy this command, go into the terminal, paste it in, hit enter my password. So I've already got this installed. Obviously, I wanted to test everything so I didn't lead anyone astray. So the next thing we need to do is install the CLI. So I can just copy this, again, paste that in. And once again, I've already got all these packages installed. All right, after we get that set up, we just scroll down and it says Run QMK Setup. Now in this process, I did come across a couple of weird things that I wanted to point out. So I do have them all fixed, but it does say that I've got, a different version of AVR-GCC. That's actually fine. It doesn't cause any real issues on my setup. It does, though, recommend downgrading to version 8. I'm on version 14, so I'm way past the version. And I think one of the issues was it can, at times, create larger files, and that could be a problem if you run out of memory on your board. But more importantly, whenever I ran this the first time, there were a couple of errors that I had to solve. And one of those problems on Linux relates to UDEV rules. So for these UDEV rules, we've got a file that's listed right here. And if you click and download it, it tells you where you need to install that. So it'll be, you go to root, go to etc, find the UDEV folder. There, if you don't have a rules.d folder, just create one and place the file that you downloaded there. The other problem I had was one of the dependencies, and I can't remember exactly which one, had some sort of version issue with Fedora, and it did seem more like a Fedora problem, that the Fedora library hasn't been updated in a bit. It couldn't find a version that was good for Fedora 40. If you have that problem, the solution was that you go into the QMK Firmware folder, and that's in your home directory. Inside of that folder, you're going to go into util, and then you are going to go into the install folder. And in this folder, there's just various scripts for Linux distributions, and I'm sure it just contains some specific stuff for each one about how to install this and that. So if you click on the fedora.sh file and edit it, you need to change this version ID to your Fedora version. So I've got it here changed to 40, and that way whenever I run my setup, so I think it's on this libusb devel that it's looking for some version. This is just telling it, hey, if you see that, just skip it. It will work. It just is telling it to skip that on this version of Fedora. Now, at that point, everything should be set up and ready to use. And so the next thing that we need to do is actually create a key map for this keyboard. And one nice thing about QMK is that they actually have an online configurator, and it has what we need kind of already in it. So what I'm going to do is under keyboards, I'm just going to search for the Dactyl. And if I scroll down here, you'll see the Dactyl Manuform 6x7. That is the keyboard that I am building. And so this is the default layout for that keyboard within QMK. Now, this is where you can update this to be whatever you want. You've got multiple layers that you can set up. You can assign different keys for how to change different layers. That's way too in-depth to really get into right now, but let me go ahead and the nice thing about this is it lets you download or upload JSON files for your configuration. So once you use this, you can just download your file, and if you ever want to edit it, you can upload it again. So if I open this up, I can import my key map. So this is my current key map. I'm probably going to change it over time. I just wanted something to check to make sure that everything worked. It's not the best. I mean, again, there will be changes, but let's just run with it. So once you get done kind of editing everything, I do want to point out right now a little bit of how everything is going to work. So the way QMK works is everything here is in a big matrix. So here in the upper left, this is basically 0, 0. And so it's the 0th column and the 0th row. You can double check that by up here in settings, changing the legend from keymap into the row and column. So the way this thing works, it's a giant matrix. And so up here on the upper left, this says 0, 0, and that means this is the first row and the first column. Now, the way these things work is you're going to have all these rows on the left, all the way down through the thumbs here, and then it starts over on the right-hand side. So the top row on the right-hand side is actually the 7th row in the overall matrix, and that means the first column on the right-hand side is the same as the first column on the left-hand side, right? So this is column 0, but so is this. And the reason that's important is when you wire up your keyboards, the thing that's on the leftmost on the right-hand side has to be wired to the same pin on its respective board as the thing that's on the leftmost of the leftmost side, because whatever maps in here, that pin on the left board has to use the same pin on the right board to access this column. Same thing for the rows. The rows, you know, the first or top row has to use the same pin on both boards. So again, that's just going to be important because if you have wiring problems, it can be weird because what may happen is on one side, that PCB may have to be wired inversely from the way the other one is from how you're thinking, meaning the thumbs are not going to be on the same pins. The pinkies aren't going to be on the same pins. It basically goes left to right across the whole thing and then starts over left to right on the right-hand side. Also in here, you can flip it over to be index, and if you get any errors on a specific key, this would be a good reference that you can come in here and see, hey, which key messed up. Now, back to the key map, if you hover over a key, it will kind of give you an indication of what the name in code for this key will be. So key H here is KC sub H. And you can basically just drag and drop anything off this bottom board. You can also see as I mouse over the keys here, it tells you what different things are. To switch layers, that's a quantum button. So if you come into quantum, you'll see I've got MO1. This button on this keyboard will basically, if I hold it down, it will work like a function key and access layer 1 on this keyboard. So layer 1 is just a different key map, so it works a bit like a function key. But once you get everything set up, you just download your JSON file. Now back to the tutorial, they actually tell you to go ahead and do some test compiling. Feel free to do that if you want, but since we're working with our own key map, we're now going to move on to building our first firmware. Okay, so it says we could configure our build environment defaults. I'm not going to worry about that. The thing that I do want you to do, if you're going to be doing this the way I did, is do a new key map right here. Okay, so it says QMK new dash keymap dash KB and then enter the keyboard name. So if I bring the terminal over, the way this thing needs to work, so I'm going to do QMK new dash keymap, right, dash KB. So I'm basically saying, hey, create a new key map for this particular keyboard that I'm about to name. So let's cover how this needs to be referenced because it will not be a direct kind of file path to a particular file. Here's the way things work with QMK. So QMK installs to a directory in your home folder, and if you're on Windows, I think it puts it in your user file path. So it'll be like, users, then your username, and then you'll see QMK sub firmware in there. So within this, there's a folder called keyboards, and this is where it holds all the keyboards. And this is everything that is already built by the community. So within keyboards, the one that I'm going to be looking at is actually under the folder hand wired. Okay, so I go to hand wired, and it's called a Dactyl Manuform. So I scroll down and here, Dactyl Manuform. And then I am doing the 6x7. Okay, so here you'll see a keyboard.json. This is the file for the keyboard, but you don't have to point straight to it. QMK uses file locations to kind of reference other build data along the way. And so what I need to do is point it basically to this folder, but it already knows that I'm in the QMK firmware folders, and it knows that this has to be a keyboard. So I actually don't put the file path, I just put hand wired, which is the name of the keyboard, and then I put Dactyl Manuform, and then I say I am doing the 6x7 version. So it's not the full file path, it's just this. Now, whenever I put that there, hit enter, it says, what is your GitHub username? Because if you want to tie this to Git, you can. I'm just going to call it test, and it will drop in a new folder ready to accept a key map there in my file path. So I go back into Dolphin, and here you'll see key maps. And so this is where it puts the key maps. If I go into key maps, you'll see a new folder called test. Within test, there's a little default key map already set up. Now, I'm not going to use this, so I'm going to delete that file. Then I'm going to go get the JSON file that I downloaded off the internet, and then I'm just going to paste it in there. Now, I know that the file that I got rid of was a .c file, and this is a JSON file. That's fine. It can actually use either. But now this file contains my custom key map, and it knows that, hey, there's a new key map here because I created one. So at this point, I'm not far from being able to flash my firmware, but I do need to change some things for the way I wired everything as far as the pins that I used on my boards. So if I go back to the 6x7 and this JSON, this is where I can modify things. Within this file, this contains a lot of information about my specific keyboard that I built. And so I can change the name, I can change the manufacturer. So if I want to put in Tech Dregs there. So it's got a bunch of other options. I'm going to change the NKRO to true. This is in-key rollover. Some other things to be aware of. This WS2812, that's the default setup here includes LED control, and that's an LED controller. And here's where we probably need to talk about the way the pins are named in this file, because here you'll see the rows and columns pins, and these have to correspond to the pins you used on the Arduino Pro Micro. So here I have a picture of the Arduino Pro Micro, and the important thing that I've learned is they use within this project these PB, PF, PD, the P columns basically. Those are the pin names that you need to use, but without the P's. They used, I think, the ones from the actual Atmel chip itself, not what the Arduino system names them. So I used from, down here where it says pin 9, I used on the left here the bottom 6, and then I skipped one, and then I went to this pin. Now the reason why is this pin with a circle on it with a 3, that is pin D0. Now within my configuration, pin D0 is the one that is set for the soft serial, so that's actually the pin that links the two Arduinos together. So that pin D0 is the one that I used via the headphone jacks to connect the left and right side. So I couldn't use it for the rows or the columns, but the columns here, it has D4 through D1. Well, that corresponds to this D4, and then it comes down and loops back. Well, I kind of went from the bottom up, so I need to reverse these. I need to go B5, B4, E6, D7, C6, D4, and then D1. And that's the way that mine's wired. And this corresponds to left to right on my actual wiring. And again, this has to be the same left to right on the right-hand side as well. Now on the rows, it goes top to bottom. So you'll see here it starts with F5 and goes down to B6. So the only change there is that I didn't use F5 and I only have 6. So that means mine, the top row is actually F6. So what I need to do is basically I'm going to cut this out, and then at the end, put a comma, and put the F5 at the end. It will end up not being used, and that's okay. I don't need it. But that's how I change my pins. So that, again, the first pin on the columns, that's going to be the leftmost column on each keyboard, and then the first row pin will be the topmost row on each keyboard, and then, again, in order, rows and columns. Now the soft serial pin, again, that one needs to be whatever actual pin you used. And with that D0, again, it's not D0 like the RX pin, it's PD0 because they use different names than, again, just the digital pins that you might be familiar with from like Arduino projects. There are a couple other things that I need to edit in here on the serial communication. So here where it says split, this is how you tell it that we're using a split keyboard, and it is enabled, that's fine. But there's something else we want to do. Whenever you plug this thing in, the two Arduinos have to decide which one is the master and which one will be the slave. So the option there that I need to use is called USB detect. And then I need to open some curly braces, and I need to give it an enabled true. And so now I've got this little, and actually I need a comma right there. So now it's basically saying, hey, whenever this thing gets plugged in, whichever side starts talking over the USB interface, that one's going to be the master. And this means I'll be able to plug it into either side. But the next thing I need to deal with is typically when you plug it in, whichever side is plugged in is assumed to be the left-hand side. So the way I'm going to change that is I'm going to save this file, and then I'm going to go back into the Dactyl Manuform folder. So I'm going up a level, and I'm going to open up the config.h, and within here, I'm going to set define EE hands. And this means that whenever I upload the firmware, I have to tell it each time I upload each Arduino which side that's on, and it will store that hand configuration within that specific Arduino. So I can tell each Arduino, hey, you will always be left or you will always be right. And what this means now is that, let me go ahead and save this. Whenever I plug this in, it doesn't matter which side I plug it into. I can plug it in on the right side, I can plug it on the left side. They will automatically figure out which one's master, which one's slave, and they will keep their hand configurations because one will know, hey, I'm the left always, the other will know I'm the right always. So at this point, we are ready to build and install this thing. So back into the terminal, we're gonna do QMK, flash, the keyboard, hand wired, Dactyl Manuform 6x7 -KM. So what keymap are we using? We're using the test. The next thing is I need to give it a bootloader option. And this bootloader option is how I'm going to tell it which side I am flashing. So since I'm using the Pro Micros, these are Arduinos, it'll be AVR dude split left. Okay, now I need to flash the left side board first if this is what I'm using. There's also split right, and that would be for the right side. So I'm going to do the left side first, so let's do left. It's probably a good idea to separate the keyboards at this point just in case. I've done it both ways and it's worked, but just to be safe, I disconnect them. So what I'm going to do is I'm going to hit enter. It's going to go ahead and compile and build and start to flash, but the way this works is I don't actually have the Arduino plugged in yet, and it will wait once it compiles for you to activate the bootloader. So before we do that, let me show you on these Arduino Pro Micros because they're a pain in the butt to get into the bootloader. So back to this picture, you'll see this reset pin, and that thing needs to be taken to ground momentarily to enable the bootloader, or else it won't work. So what I did is whenever I plug these things in, you'll hear it plug in. While the QMK software is looking for the board to do the upload, I'll briefly take that jumper, touch the reset and the ground right next to it together. You got to do that like twice and give it a second, and then the bootloader will open up and then it will go ahead and flash. So to show you, I hit enter. Okay, so it's going to build everything out. It says, all right, waiting for the serial port. So I'm going to plug this thing in. All right, grab my jumper, and now touch the reset ground. There it goes. And now it's going to flash. And now I'm going to unplug. Or actually, by the way, right now, before I unplug, just to verify. All right, so yeah, I've got the keys are working. So now I can do the right side. So let me unplug this up. Now I can do right, hit enter, and do the same process. It says, all right, now waiting for the serial port. Plug that in. Now I've just got to make contact, and there it goes. So it's going to flash the right-hand side, and we're done. So now I'm going to unplug this. I'm going to plug the sides together, and now we're ready to do a test. So if we go back to the online configurator tool, you'll see right here it says test keyboard input. So if I click on that, it pulls up this screen. Now I'm going to plug in the left-hand side of my keyboard, and there we go. Took it a second, but yep, I've got keys. And this is how you can test, hey, is everything mapped out the way you wanted it? Just to double check. Now I am going to reset this. I'm going to unplug. Now if I plug it into the right side, because that was the left side, this is just me checking, does that USB split configuration work? All right, so let's test. Plugged into the right side. And yeah, that's my home row. Yep. So right-hand side, oh yeah. So I've got that key, man, those brackets, I've got something I need to work on. I got a couple of sticky keys. My P key and that bracket key are both kind of sluggish, so I think I've got some hot glue that kind of got down into the key switch, so I need to get those cleaned up. But it's working, and that's how you flash these things. So it took me a while. It took me hours banging through some problems to have figured out how to do the pins and how everything needed to be set up and how QMK worked. It's all working now. So now we just got to get this thing buttoned up and we're finished. So I've got the keyboard plugged in and it does work. It's not easy to use because it's a totally different kind of setup that I'm used to. I'm certainly used to flat keyboards. So it's going to take some time to figure out my typing here. You know, so like whatever I'm typing, I'm making a ton of errors, but you know, it is working. So I figure I'd wrap this up with talking a little bit about the overall project and how I kind of feel about it. And I would say that, you know, making your own keyboard like this, I don't know. It could go either way, kind of depending on how you look at things. So first, let's talk about cost. You have to buy a bunch of key switches. You've got to buy all your keycaps. You've got probably a whole spool of filament, you know, a whole kilogram of PLA. Once you get through the errors and like if you have any print errors, and these are big, long, complicated prints, I had to print multiple versions of each side just to, you know, get everything kind of the way I wanted it. So, you know, I easily went through a whole kilogram of filament on these. You've got a couple of Arduino Pro Micros involved, and then all of the wiring, the solder, the diodes, kind of, you know, everything else, the 1/8 inch cable, and then the jacks for it. So it takes a little bit of hardware. I'd say you'd be hard pressed to build this for under $100. And, you know, then you end up with a keyboard that is going to be different, and it's hard to know whether or not you're going to like this until you kind of use it. I don't know if I'm actually going to end up liking this, and you can't easily get all the parts back off. I mean, the keycaps and the Arduinos are fine, but I've got all the switches soldered in and hot glued, so it would be a ton of work to recover these key switches. So I would really count the cost before you go out and build one of these. Do you really, really want this? Because you are going to sink some money and a lot of time. There are, you know, a lot of hours sunk into this project. There are, you know, probably a couple days of prints because of the errors and tweaking stuff from one version to the next. You know, you've got all the fiddling, the programming, the wiring took hours. It's a lot of work. It's a lot of work and it's not cheap. Now, on the other hand, you know, Ergo split keyboards, the commercial versions, you're spending $400 or $500 or more. So from that standpoint, yeah, if your time and effort is, you know, not overly valuable to you and you feel like doing this as a project and you're very confident in the layout that you're going to like this, then maybe, yeah, it's something that you might take a look at. I also found that the documentation of like the Dactyl Manuform project was okay, but there were a lot of gaps. There were a lot of details that were not specified with exactly how particular the wiring had to be. And it took me several hours of just digging through documentation to figure out exactly where I went wrong in a couple places. So that's another thing to keep in mind. It is a lot of work to get this thing going. But once you have it done, you've got it. And so now I'll get to use this and I'll figure out, did I waste all my time building this thing? But with that, I'm going to wrap this thing up. My overall thoughts are this was a heck of a lot of work. I don't think I'd want to do it again, but I will be interested to see kind of over time if I can adjust to this keyboard and whether I actually like it or whether I've wasted all my time. With that, I appreciate your time as always. And if you have any feedback, comments, or questions, feel free to leave them down below in a comment. Thanks.